Hello viewers, कैसे आप सब लोग? Hope you are doing well. So in the last lecture, lecture number 11, we have studied how to find the distance, that is shortest distance between two skew lines. What are the skew concept of skew lines? The lines in space neither parallel nor intersecting. We have used the mathematical model like that. If these two lines are skew lines, that is they are neither parallel nor intersecting, then this is the shortest distance between the skew lines, and we have found the formula in vector form and Cartesian form. Now in today's lecture, lecture number 12, we are going to find the shortest distance between two lines in the space where the lines are parallel. That is, take this model. If we consider this as two lines in space, and if they are parallel, what is the shortest distance between them? This is nothing but here. This is nothing but the perpendicular distance between the two lines. So we are going to find the shortest distance between the two lines in space in today's lecture, lecture number 12. So without wasting any time, let's go to the blackboard. So here, first a note, very important note to you, that if you directly come to this lecture, lecture number 12, to understand all the concepts easily, please go through all the previous lectures, especially lecture 7, and then come to this video, then you can get all the concepts very easily. Thank you. So distance between parallel lines. First we will draw the diagrams. These are the two lines which are parallel to each other. Say this one line 1, say this one line 2. Now let L1 and L2 be two lines, parallel lines, be two parallel lines in space whose equations are R vector A1 vector plus lambda times B vector, and R vector equal to A2 vector plus mu times B vector, where lambda and mu are nothing but non-zero scalars. This one line 1, this one line 2. So as the lines are parallel to each other, they are coplanar. This lie in the same plane. See, if two lines in space are parallel to each other, we can draw a plane containing both two lines. So they are lying in the same plane. That is, they are nothing but coplanar. Okay. So in the diagram, first we will understand the proof from the diagram. Okay. So here, say, take this point S, whose position vector is A1 vector, and here take another point T, whose position vector is A2 vector. Join these 2 points T like that. Okay, and draw foot of the perpendicular on the line L1, say point P, from the point T on line L2. So P is the foot of the perpendicular drawn from the point T on the line L1. Okay, so this PT, that is it is the perpendicular distance between the lines L1 and L2. So we are going to find the magnitude of the PT vector. Then we are done, because the magnitude of the PT vector is the required shortest distance between the two parallel lines. Okay. So here let S be a point on line L1 with position vector A1 vector, and T be a point on line L2 with position vector A2 vector. Therefore, ST vector equal to what? ST vector equal to A2 vector minus A1 vector. Here we have used the triangular law of vector addition. You just go through vector chapter, you can understand this very easily. Okay, now next page. Let ST vector makes an angle theta with the line L1. See previous page. Let ST vector makes an angle theta with the line L1. But see the equation of line L1. Equation of L1 is R vector equal to A1 vector plus lambda times B vector. That's why I have requested you to go through the previous lectures, especially lecture number 7. In lecture number 7, what we have learned? Equation of a line passing through a given point and parallel to a given vector. These equations are in that form. Line L1 and line L2 are given in which form? Equation of, they are nothing but equations of lines parallel to a given vector and passing through a given point. Here in for line L1, point is A1 vector, and for line L2 the particular point is A2 vector, and for both the lines they are parallel to the B vector, because as the lines, both the lines are parallel. So here in both cases we have taken B vector. Have you understood this? If you have any doubt, put your comment in the comment section below. I will again explain this to you. Next, here as L1 vector, line L1 is parallel to B vector, because equation of line L1 is what? Equation of line L1, R vector is 1, A vector plus lambda times B vector. So line L1 is parallel to, as line L1 is R vector equal to A1 vector plus lambda times B vector. Therefore line L1 is parallel to B vector. So line, this is L1, say this one is parallel to B vector, and we have considered here, we have assumed here ST vector makes an angle theta with the line L1. So here if ST vector, this is ST vector, say if ST vector makes an angle theta with L1, then automatically ST vector makes angle theta with B vector. It is a coincidence, right? So therefore ST vector makes angle theta with B vector. Now we will consider the cross product of B vector and ST vector. B vector cross ST vector means what? B vector magnitude, ST vector magnitude, sin theta, n cap. What is n cap? From the definition of vector product, we know that this n cap is nothing but a unit vector perpendicular to both ST vector and B vector. Here, where n cap is a unit vector perpendicular to both B vector and ST vector. Okay. Now we will take the magnitude. Say this is relation 1. Relation 1. Okay. Now we take the magnitude of relation 1. Now in the next page we will take magnitude of B vector cross ST vector equal to what? Magnitude of B vector, magnitude of ST vector will remain same, sin theta, and magnitude of n cap is 1 because n cap is a unit vector. Very simple, nothing is there. So previous page, B vector magnitude, ST vector magnitude, sin theta. Now from the diagram, if we consider this triangle STP, what is sin theta? Sin theta equal to nothing but what? Perpendicular by hypotenuse. So PT by ST. We will use this in the relation. Sin theta equal to, but sin theta equal to PT by ST. Therefore PT equal to ST sin theta. For PT, ST all are vectors. So now we have magnitude of B cross ST vector equal to B vector and PT vector magnitude. We can write this using this relation. So, but what is PT vector? See, this is PT vector. PT vector magnitude means we have discussed earlier in the today's lecture that PT vector magnitude is nothing but the shortest distance between two the parallel lines given here, which are L1 and L2. So therefore PT vector magnitude equals to B vector cross ST vector magnitude by B vector magnitude. Take whole magnitude to make the thing positive. So this is the vector form formula, you can say formula in vector form, which will give the distance between two parallel lines. So relation 2 is the distance between two parallel lines in vector form. Now, as always, we have to find the formula in Cartesian form also, because it will be of great advantage while solving the problems. Okay, so we have PT vector Cartesian form. Okay, Cartesian form. Okay, so the distance between two parallel lines is, from the previous page we see that B vector cross ST vector, B vector cross ST vector magnitude by B vector magnitude. Now what is ST vector? We have derived it. ST vector A2 vector minus A1 vector, while we have written this here. ST vector equal to A2 vector minus A1 vector. We just simply put the value. B vector cross A2 vector minus A1 vector magnitude by B vector magnitude. So this is, say, relation 4. Relation 3, I think. 3. Okay. So the distance between the two parallel lines is this. So we have proved the theorem. Now we will see one application of today's theory. So we are going to solve one problem right now in the next slide. Okay. So that is today's problem. Find the distance between the lines L1 and L2 given by L1 is this, L2 is this. Here observe that r vector equal to I cap plus 2j cap minus 4k cap plus lambda times one vector, and equation of line L2 is 3i cap plus 3j cap minus 5k cap plus mu times one vector. This particular one vector, observe minutely, these are same. Why these are same? Because that is the trick to identify whether the two given lines in the problem are parallel or not parallel. Here these lines, this vector, that is lambda times this vector, mu times this vector is same. So these two lines are parallel to each other. Again we are using the concept of lecture number 7, that is a equation of a line in space passing through a given point and parallel to a given vector. Here you just understand, if this is line L1 and if the green line we consider as line L2, then if we follow theory of lecture 7, from this equation of line L1 we can say that this L1 is passing through a particular point whose coordinates are 1, 2, minus 4. Say this is A1 vector, take the pen, another ink, white. Okay. If this is A1 vector passing through, this is line L1 and this is particular point passing through A1 vector, then A1 vector coordinates of A1 vector are 1, 2, minus 4, and this line L1 is passing through this point and parallel to this vector, say B1 vector. So line L1 is parallel to B1 vector. Direction ratios of B1 vector are what? Direction ratios of B1 vector are 2, 3, 6. From the equation given in the problem, we directly write these values. Again, say this is line 2. From the equation of line 2, if we just go through the lecture number 7, we can easily write down that this line 2 passing through a particular point, say whose position vector is A2 vector, then coordinates of A2 vector are 3, 3, minus 5, and these also parallel to a, say if you say B2 vector, then direction ratios of B2 vector, direction ratios of B2 vector are what? From this we can say 2, 3, 6. Now B1 vector and B2 vector are two vectors whose direction ratios are same. That is, we know from the lecture number 1 that if two parallel lines always have same set of direction ratios or direction cosines, that is, the direction ratios or cosines are proportional to each other if two lines are parallel. So B1 vector and B2 vector are parallel. Actually they are same vector, because here, so line 1 parallel to B1 vector, actually B vector 2i plus 3j 6k cap, actually one vector is given here, and line 2 is also parallel to B2 vector. B2 vector is B vector. B vector is nothing but in that case 2i cap plus 3j cap plus 6k cap. So this line L1 and L2 is both parallel to B vector. So this line, say L1 is parallel to B vector, say and this line L2 again parallel to B vector. So these two lines L1 and L2 are parallel. So this is how from the given problem we can determine whether the two lines are parallel or not parallel. We have to just check this vector. If these two vectors are identical, then we can say they are parallel. If they are not identical, that is they are different vectors, then they must be non-parallel lines. So in that case, the direction ratios should not be proportional to each other. So we have discussed the trick how to determine the lines are parallel or not parallel. Now we are going to find the distance, that is shortest distance between these two parallel lines. So here next page we have determined A1 vector and A2 vector. Here coordinates of A1 vector. First we write like this, comparing the equations of lines L1 and L2 with R vector equal to A1 vector plus lambda times B vector and R vector equal to A2 vector plus mu times B vector. We have A1 vector equal to previous page 1, 2, minus 4. 1, 2, minus 4. A2 vector equal to, that is the coordinates of the points. Okay, previous page A2 vector 3, 3, minus 5. 3, 3, minus 5. Also B vector, direction ratios and direction ratios of B vector are 2, 3, 6. 2, 3, 6. Now we are going to use the formula. So therefore required distance between, find the distance between the lines. So required distance between the lines are, we just simply use the Cartesian form. See here, B cross A2 vector minus A1 vector B vector cross A2 vector minus A1 vector by B vector magnitude. So here again we will use the concept of vector product, that is cross product of vector chapter. So this is B vector cross this. So I determinant, we will take determinant I, j, k cap. What are the components of B vector? 2, 3, 6. 2, 3, 6. And what are the components of A2 vector minus A1 vector? This is A2 vector, components of A2 vector, this is components of A1 vector. So A2 vector minus A1 vector means 3 minus 1 is 2, 3 minus 2, 1, minus 5, minus of minus 4, plus 4, so minus 1. So here components of B vector I have written, components of A2 vector minus A1 vector I have written. So close the determinant by magnitude of B vector. What is the magnitude of B vector? 2 square 4, 3 square 9, 36 equal to, take whole magnitude. So I cap minus 3 minus 6 minus j cap minus 2 minus 12 plus k cap 2 minus 6 take magnitude by here it is 36 plus 4 40 49 7. So here we will go to the next. So minus 3 minus 6 minus 9 I cap minus 9 I cap previous page minus 2 minus 12 minus 14 here also minus sign, so plus 14 j cap previous page minus 4 k cap by 7. So now what is the magnitude of this vector? Square root of 9 square 81, 14 square will derive 16. What is 14 square? 14 into 14. So we are going to use the short trick of multiplication here. 4 4 16, 4 4 is 8 and 1. So 6 9 1 196. If you ask me to show the short trick of this multiplication, I will make a separate video for this. Put your comment in the comment section below that you require this short trick of multiplication by 7. So here 196 plus 81 plus 16 means 13 1. So here 19 19 1 2 293 root by 7. Answer. Is this the answer? Have you finished? No. You have to mention this. Always mention this unit. We don't know here it is centimeter or millimeter or kilometer. So we just mention unit. Now the answer completes. So that's all for today's lecture. Hope you have enjoyed today's lecture a lot. Thank you.